Hello everyone, welcome to another exciting episode of DSA, and today's problem is about binary tree. So we are given two different integer array, pre-order traversal and post-order traversal output of a given binary tree. Our job is to reconstruct the binary tree and return the root of the binary tree as an output. Okay. So from the definition of a binary tree, we know there is going to be a root and there is going to be a left child and there is going to be a right child. That is a very simple and basic idea of a binary tree, right? And there are three types of traversal. One is a pre-order, post-order, and in-order traversal. The definition of pre-order traversal says that we are going to read the root first, then a left child, and then right child, and it is recursively happen for all the subtrees. Okay. Similarly, for the post-order traversal, it's going to be left child, then right child, then the root. Okay, and similarly is going to happen for all the subtrees. Okay. So from this to definition, we can easily say the first element of the pre-order traversal output is going to be the root of the tree. And similarly, the last element of the post-order traversal output is going to be the root of the tree. And they are going to be the same, right? If they are not same, then we can simply raise an exception that we cannot construct a binary tree from this to output, right? Now, in this example, they are same, right? So we can easily say that we are going to construct a binary tree from here. So 1 is our root, right? Node 1, that is the root of the binary tree. Now after that, we have this much of element left. Then from this element, from this much of element, we have to construct the binary tree. So let's talk about 2, 4, 5, 3, 6, 7. So definitely 2 is the root of the left subtree, right? Because from the definition of pre-order traversal, after root, we are going to read the left child, or rather left subtree. Okay, so definitely is going to be 2 here. Now we have 4 and 5. Now let's take a look at the post-order traversal. The post-order traversal says that we are going to read the left child first, right child first, and after that we are going to read the root. So it's 4, 5, 2. Similarly, the index, we can see that the index of 2 is 2 here, right? So that means there are 3 elements in our left subtree. So it's going to be 2, then 4, then definitely 5. So at this point, we have successfully created our left subtree. Now after this, we are going to create a right subtree, which is going to be 3, 6, 7. So definitely 3 is going to be the right, the root of the right subtree. And from the post order traversal, we can say 6 is going to be the left child and 7 is going to be the right child. Okay. Now it's very much easy to construct this problem using a small or a small example where the data element number of elements are very less. Now to find out the actual algorithm, we need to talk about a bigger example. Okay, let's say it's like 1, then 2, 3, 4, 5, 6, 7, 9. Okay, then say 33, 11, 22. Okay. Now, after that, we're going to have, let's say, a 9, 7, 6, 5, 4, 3, 2. So our algorithm is going to be, we are going to find out the index of first element of our left subtree in the post order traversal. Then we are going to find out the depth of the left subtree, which in this case is going to be I mean not the depth, the size of the left subtree is going to be 7 elements. And then we are going to construct the left subtree, and the rest of the element is going to be the right subtree, right? This is step 1. Now in step 2, we are going to play a recursion, right? From here again, we are going to create a left subtree and a right subtree until we reach to the child. Okay, so this is the algorithm we are going to use to solve this problem. So let's hit the board. First things first, let's do some preliminary checking if Pre-order, sorry, if not pre-order or not, sorry, my mistake, or not post order, then we are going to return none. That means the tree is itself a empty tree, an empty tree. Okay. After that, we are going to say that if pre-order 0 is not equal to post order -1, then we are going to raise an exception, not a valid tree. Now this is lead code, by the way. So in the lead code, the question is already saying that the pre-order and post-order traversal, both of them are from a valid binary tree. So this line 11 and line 12 doesn't have any valid scenario. So we are going to omit that. But when you are sitting in an interview table, make sure you cover most of the edge cases, because that's what the interviewer is actually looking into you. Okay. So when we have this, after that we're going to find out the root of the tree, and as I said, the root is going to be the first element of our pre-order traversal, right? And then we are going to find out if length of pre-order is going to equal to 1, that is the base case of our recursion. We are going to return the root, right? If not, then we are going to say root dot left. Sorry, we are going to have the left child, right? Left child is going to be pre-order of 1 and left subtree size. Now I have done it using left subtree. You can do it using right subtree as well, but that's going to be tricky and little bit of difficult to map and imagine. Okay, but again, it's up to you. There are many ways to solve a problem, so it's up to you how you're going to do it. Okay, so left subtree size is going to be post order traversal, post order dot index of left child plus 1. But why plus 1? Because we all know that Python list is a zero index base. So we are going to add an plus 1 so to make the actual size, to calculate the actual size. After that, we are going to call the recursion. So root dot left is going to be self dot, let's copy this, and in here we will write first thing will be pre-order, pre-order of. Now, if we take a look at the board, pre-order of 1. That means the first element is going to be the root, so we all know that. So we are not going to consider that. So 1 colon. And how long we are going to traverse? Left subtree size plus 1. But why plus 1? Because we are not considering the first element, right? So that's why pre-order is going to be left subtree size plus 1. Similarly, post order is going to be left subtree size plus 1 colon. Okay, so that is what our root dot left means. Okay, so that means from here to here. Okay, now what should be our left? This is our left subtree. Now what could be our right subtree? I'm going to just put right here, and it's pretty simple. It's very simple. The pre-order is going to be left subtree size plus 1 colon, sorry, my bad, it's going to be, okay, left subtree size plus 1 colon, and the post order is going to be the last, all the elements except the last one, so minus 1. Okay, now let's return the root, return root. Let's run it. Okay, there's a problem. The int object has no at. Oh, my bad. Root is not. My bad. I forget to convert it to tree node. So it's going to be tree node. Yep. Okay. Let's see. Let's see. Yep. We did it. So this is the Python program of reconstruct a binary tree from the pre-order and post-order traversal output. So I hope you guys understood the problem and how I solve it, grasp the idea, and like if you like the video, definitely please do subscribe and like and share. Okay, I'll keep on bringing such interesting content, and till then, goodbye.